In this video, I'm going to revisit the example we just did and show you how we could have done all that work in Google Sheets. So I've gone ahead and typed into a Google Sheet the information from that example we were doing, although I didn't bother typing out the actual what the categories were. I just typed 1 through 7 because there's 7 categories. It doesn't really matter what the names of the categories are for our purposes here. By the way, just a little bit more information about using Sheets. Notice the word category doesn't show completely there. If I put my cursor up on the column heading, you can see I get that little right arrow, so I can drag the column to be wider. Another thing you can do is when you get that arrow, if you double click there, it will automatically size the column to be exactly the size it needs to be to fit everything in. Okay, so I've typed in our observed values from that table that we developed in the note and the expected values. And then to get our test statistic, our chi-square, remember we do observed value minus expected value squared, and then divide by the expected value. And after we do that for each category, we'll add them up. So I'm going to click in the first box under that formula. That formula, by the way, is just there to remind me of what the formula is. It's just really a column heading. Doesn't have any function. Now, to perform a calculation in a spreadsheet, you first hit equal, and then you enter the formula. So I need parentheses. And now I want to put in the observed value for this row. And I have two ways of doing it. So I'll first show you the first way. If you just click on that box, the cell, notice that over here now it says B2. So that's the first number that I'm using. And then I want to subtract the expected value from that row. Again, I can click the cell and automatically the name of the cell, C2, will be entered. Notice that what you get is the name of the cell, not the number that's in it. And what that's telling you is that this computation is going to use whatever number you put in that cell. So I could go back and change the number in the cell, and this computation would automatically use the new number. Then to square something, you use that little up arrow that it's above the 6 key on my keyboard. Squared, put the exponent in. So that little up arrow is saying next comes an exponent. Then I want to divide by the expected value in that row. So I click in the box and then I hit enter and I get the answer to that computation. Now I'll do this one more time in a slightly different way, and then I'll show you how you can shortcut all the rest of them. So I hit equals to tell it we're doing a computation now. If you don't hit equals, you won't get numerical values. Maybe I should show you that. So if I just do, yeah, nothing happens if I click over there. Okay, so you need the equals. Okay, now I'm going to again do observed value minus expected value. If I want, I can type in the name of the cell where my number is. So this is cell B3. So I can type B3 minus, and notice now it's telling me that I selected this cell, even though I typed it instead of clicking on it. Then the expected value is in cell C3, so I type C3, close my parentheses, and you can see they're both have dotted lines around them to indicate that those are being used. Then we do it's called a caret actually, but anyway, it's a little pointer upper thing, squared and divided by the number in C3. Hit enter and you get your numerical answer. Now, we don't have to keep on entering the formula for all of these. What you can do is click the last cell that you entered a formula into, and notice in the lower right hand corner there's a little square. If you put your cursor over that square, it turns into a cross, and if you now click and drag down, it will apply that exact formula, but it will adjust for every line. So for example, if I click in let me do the last one. So if I click there, the way you can see what the formula is, you have to go up to this bar up here. I think it's even called the formula bar. And notice it says B8 minus C8 squared divided by C8. So B8 is the observed value in that line. C8 is the expected value in that line. So when you hover over the little square to get the cross and drag down, it gives the same formula or same calculation, but adjusted for each row. So it assumes that you want to do that same calculation, but for the next row. Same calculation, but for the next row. Okay, so that's all our O minus E squareds over E. I need to add those up, so I'm going to do a computation, which means I need to start with an equals. By the way, I typed in here, and maybe I should give you a chance to type in a label for this next cell, that it's our test statistic and it's a chi-square. And I put the equals in just because it looked better to me. Okay, so now I hit equals to do a computation, and we're adding up the stuff above. So I'm going to type in sum, S-U-M, and notice it even gives us a hint that that might be what we want to do. Usually people, if you have a list of numbers, people are either adding them up or taking an average. We're adding them up. So I type sum, and then I have two ways of doing this. The fastest way is just to click and drag to select all those cells, and then you close your parentheses. And so this is saying we will add up all the numbers from E2 through E8. The other way you can do that, if you don't like dragging to select things, which some people don't, you can type the name of the first cell that you're going to use. So that would be E2, and then you put a colon, and then you put the name of the last cell you want in the computation. So E8. Oops. 8. Close your parentheses and hit equal. So you can do that either way. Now that we have our chi-square, we can get the p-value. And I've put a note here that we'll be using the function chi-dist. That stands for chi-distribution, and it needs to be preceded by an equals. So I'll click on the box. I'll click on the box, type equals, and if you start typing chi, you get this list of functions you can use. And we want chi-dist. You can type it in or just click on it. Now, next you get something that tells you what to enter in the parentheses. The x is your chi-squared, so they don't have a chi apparently to put, so x is supposed to tell you you're putting in a chi-squared. I'm going to click the box that has my chi-square in it. That says, okay, we're going to use as your chi-square whatever number's in E9. Then you have to type a comma, then the degrees of freedom. And remember, the degrees of freedom is the number of categories minus 1. So since we have 7 categories, we have 6 degrees of freedom. Close the parentheses, hit enter. And there's our p-value. Now I'm going to show you also a super shortcut way of computing your p-value that doesn't even require you to do all this stuff. Now I wanted to go through this because I do expect that you'll know how to do this, but this super shortcut, if nothing else, is a great way of checking your p-value and make sure that you did the computations right. To do this, we use a function called chi-test. So that means chi-square test. We start out with our equals. If you start typing chi, notice here's chi test. So I'm just going to click there. And chi test up here says that you need to enter the observed range. That means the observed set of data values. Then you have a comma, then the range of expected data values, or the set of expected data values. So the observed data values goes from B2 to B8. So I can simply click and drag to highlight those. And notice B2 colon B8 shows up here, meaning I'm using everything from B2 to B8. Then I need a comma. And the hint up here, or tooltip, or whatever you want to call it, reminds me that I need a comma between the observed values and the expected values. You don't have to click and drag. So I'll do this the other way for the expected values. I can say that the expected values start at C2 and go down to C8. So I can just type that if I want. So C2 colon means go all the way through these. So C2 colon C8. And by the way, it doesn't matter if you type a capital letter or a small letter. The program, the Sheets knows that you're supposed to do that, and it even, if you accidentally type a small letter, it converts it to a capital letter up there. Notice that we got the same answer. That means that we did our computation up here correctly. And that's really it for this example.